Hi everyone, welcome to today's topic. So this is my topic number 12, and for topic number 12 I have chosen Arrhenius equations and its application. Okay, so this is from chemical kinetics and physical chemistry, and this topic is very much important for CSI and NET exam. So you must be thinking that every topic I am teaching and I am telling that topic is important, right? So that is also true. That is true because for 1 month, I am teaching you those topics which are only important for the CSI and NET. Means the questions are frequently coming from these topics. Okay, so that those topics only I am teaching you. So from that point of view, it is obviously important, but it has some added advantages which I want to tell you to gain your interest in this topic. Because first one is, it is easier to understand. No other complicated theory portions and anything is like that is not there, so that you have to try harder to understand these topics. Nothing like this is there. Only simple equation if you know, and every form of the equation if you know, and you have the simple knowledge of mathematics and graphs, you can easily solve the questions and easily understand this topic. Okay. Second important thing is, questions are frequently asked from this topic. Okay. So from every CSI and NET, if you see the questions, so questions 1 to 2 questions are there from this topic. Okay, from this small topic, and sometimes 3 to 4 questions are also there. So if you understand this topic uh, in a better way, you can solve the question 2 to 3 questions in CSI and NET easily. Okay. So next thing is that one added advantage is there is that the questions are actually uh, straightforward, like from the equation only, and you have to just compare the equation you know, and the equation is given in the question, and sometimes the graphs are given, so you have to compare the between the graphs, and sometimes the only the all data are given, you have to put the data and solve the equation. So this kind of, so every type of questions I have incorporated here in this PPT, so that you have the ideas that how what kind of questions can be asked from this topic. Okay, so please make sure you have a pen and paper with you so that you can solve with me. So let's start today's topic with a positive energy. Okay, so firstly I will be talking about temperature coefficient. So why and what are these? So let's see in the next slide. First, temperature and rate of reaction. So I have previously told you that rate of reaction is actually depends on various factors, right? So for previously, when we were studying the rate law, we have understood that the rate of reaction is proportional to the concentration of reactant molecule, right? But here power will be different, like it is the order. So it can be concentration to the power 1, 2, or various kind of concentration can be there. So like this way, right? So rate is depending on the concentration of reactant molecule. So from that only the experimental values we got, and we know about the what is the actually rate law for a particular reaction. Okay, that is a different thing. But the rate of reaction is also depends on the temperature also. Okay, so speed of reaction or rate of reaction depends on various factors. Increasing temperature of a system, rate of reaction actually increases. Okay, question mark. So how? So here it can be observed that when we increase the temperature, the rate of reaction actually increases. It is actually then experimental proof is there that not temperature directly affecting the rate of reaction, it is actually affecting the rate constant value. Okay, which depends on the unit of rate constant depends on the order, right? You remember that? And so temperature has a effect on rate constant. So increasing temperature actually the increase of rate constant happens, and which eventually increase the rate of reaction, because we know rate is equal to K, which is rate constant and concentration to the power, let's say order, X is order, right? So like that way, we can say temperature is affecting the rate or speed of reaction. But how it is affecting? So there should be some relations between these two, right? So there comes the temperature coefficient. So two kind of temperature coefficient or this equation we will see. So firstly, it is observed that when temperature is increased by 10 degrees Celsius, the rate will be increased by 2 to 3. Okay. So this is the simple form. This is K T plus 10 degree, means this is the rate constant when 10 degree increase in temperature happens, and this was the initial rate constant, and these two ratio will be 2 to 3. Okay, and like this way it will affect the rate of reaction. Second thing is that, okay, when we are talking about 10 degrees Celsius increment, then we can write like that. But it is not also a specific value. It is a rough value of the increment we can get, like 2 to 3. It should be there like that way. The firstly, it was the idea. Second thing is that when temperature is increment is not 10 degrees, what will happen then? So there was found another equation that K2 is the final rate constant, and at final temperature the rate constant is K2, and at initial temperature rate constant is K1. So phi is the actually the temperature coefficient for this equation, and here temperature coefficient is 2 to 3. Okay, and delta T is the temperature difference by 10. Okay, so these are not much important. These are only the initial idea or initial when the research are actually going on, the experiments are going on. That time these kind of formulas or equations were found by scientists. But eventually we got the Arrhenius equation. Arrhenius equation. So before going to the Arrhenius equation, this is actually the giving you the actual relation of rate constant and temperature. For any temperature, this equation for any temperature, the value of rate constant it can give. Okay. So before going to that, we have to have the idea of threshold energy and activation energy. Okay. So what is actually the threshold energy? Sometimes students are getting confused with these two terms, and they are thinking that these two are same, but there is a little difference between these two. Let's see now. So minimum amount of energy needed to convert the reactant into product. So the minimum amount of energy which is needed to convert the reactant into product. Fine. Now what is activation energy? Minimum amount of energy that is to be added to the reactant molecule to perform a reaction. These two are these two seems to be same thing, right? Same definition, but it is not. Here energy needed. So how much total energy is needed, and here it is how much energy to be added to the reactant molecule. These two are different. You don't understand? You have the question mark in your mind? Okay, stick to that point. I will make you understand with a graph. Graph means the reaction profile diagram, like this way. Reactant to product. Okay. So this is reactant and this is product. This is the energy of reactant. Okay, fine. This is the transition state of the reaction. Okay, now this is the EA. This is the activation energy for the reaction, which means the energy needed to be added to the reactant molecule to perform a reaction. When we are giving this much energy, that time reaction will happen. It is nothing like that okay, reactant has more energy, product has less energy, so reactant can go to product. This is not happen like that, because to start a reaction there should be a uh, push, or should be the energy, okay, to start a reaction, so that molecule can get collide with each other and can give the product. Okay, that is the activation energy. But now what is now threshold energy? So we understood that for any reaction activation energy is must, because reaction or reactant have to go through this kind of reaction profile diagram. This will be defined when we take the defined type of reaction, but some energy profile diagram should be there, like some activation energy will be needed for any reaction to happen. Fine. Now what is threshold energy? Threshold energy is this one. So here for activation energy we are not considering the energy of the reactant, because we are giving energy to the reactant. So this much energy will be the activation energy till the transition state, till the reactant, when the reactant till the transition state, when reactant is going to transition state, from till that point the energy is needed for uh, activating the reactant molecule to product. Fine. But threshold energy is different thing, where the whole the total energy which is needed to perform a reaction. So here reactant energy is inside this threshold energy. Means we can write threshold energy is energy of reactant and activation plus activation energy. So this is the simple definition, and in the graph, seeing the graph, you can understand that what are the difference between these two. Fine. Now Van 't Hoff equation. Why we are reading this Van 't Hoff equation? This is also very much important. So from this only we can go towards the Arrhenius equation. Carefully, please see this. d ln k equilibrium by dt equals to delta E by RT square. This is the Van 't Hoff equation. This is also a popular equation. Okay, you have to remember this also. Where K equilibrium is K2 by K1. K2 means the forward rate constant if a reaction is like that way. K1 and K2, and it is giving B. That time K equilibrium will be K2 by K1. Sorry, it will be K2. Forward by backward. Okay, K2 by K1. Next, if we put the value of K equilibrium here in this equation, what will we get? K2 by K1. Simple. So now we are taking ddt outside, and the ddt will be uh, of the ln K2 by K1. And here we are taking delta E as EA1 and EA2. EA1 and EA2 are EA1 and EA2 are the activation energies for the two states. Okay, fine. And RT square is there obviously. So now if we solve this equation, we know that if we take this ln, let's say ln a by b, okay, if we take ln a by b, we can write from here that ln a minus ln b. Like that way here it is written ln k2 minus ln k1. Okay. So now if we okay, so for K equilibrium, we know that is the ratio of the two rate constants. Okay. So if we write at equilibrium, what happens actually? K is 2, right? So K2 into A will be equal to K1 into B, right? So now B by A will be K2 by K1, right? So the forward rate constant by backward. So I was a bit confused about it. So by solving this, when you have a confusion, just solve it and you can see that you are right or wrong. Okay, so this is fine. So from this actually d ln k. So if you compare, if you actually like this way, if you okay, so like this way, if you solve this or in this manner, if you write the equation after comparison, you can see that d ln k2 by dt will be equal to ea1 by rt square and d ln k1 by dt will be ea2 by rt square. So overall we can write after comparison that d ln k by dt will be ea by rt square. Fine. Ea is here activation energy. So this is one form of Arrhenius equation. Let's see carefully. Okay. So dl and k equal to Ea by RT square into dt. Now, if we take integration, okay, here and here. So these two are constant. So these they go outside the integration sign. So ln k will be now Ea by r into 1 by 2 because we know 1 by x square dx equation, so integration will be minus 1 by 2. Okay. So minus sign is here and 1 by t is here, plus here no upper limit and lower limit is given. So there should be one constant. So constant, let's say ln a. So for constant we have taken the constant as ln a. Fine. Now we can write, okay, I am simplifying the form ln k minus ln a equal to minus delta e by r. Okay, from this we can write now from ln, the properties of ln, we can write like that ln k by a will be equal to minus delta e by rt, right? So if you now remove the ln, so ln has e base, so it will be e to the power. So k by a, sorry, here you can. So k by a will be e to the power minus delta e by r. Okay, from here you can write like this. So this is the Arrhenius equation. So it relates the rate of reaction, it relates the temperature and rate of reaction. Okay. A is here P exponential factor, E is the activation energy, T is the temperature. Fine. When T increases, so what I have said you before that increasing temperature leads to the increase of reaction rate. So when T increases, what is happening? Just see. Okay. So T increases. T increases means 1 by T will decrease when T increase. Okay, fine. So minus, let's say some constant value, minus 1 by T will be, no, 1 by T only, consider constant. Okay, minus 1 by T will be increase, as 1 by T is decreasing, minus 1 by T will be increasing order. Now we can say, so K is, okay, so minus 1 by T is increasing means e to the power minus 1 by T will be also increasing. It will be also increased, and K is proportional to e to the power minus 1 by T only. So we can say here K will be increased. Understood? Because T is when it increases, 1 by T will be decreased and minus 1 by T will be again increased, and if it is increasing in increasing order, e to the power this will be also in increasing order and K will be now increased. Okay. So when T decreases, when T decreases, okay, T decreases means 1 by T will increase, minus 1 by T will decrease, e to the power 1 by T, minus 1 by T will be again decreases. So K will decrease. Fine. So when T increases, K increases. When T decreases, K decreases. Fine. And K is proportional to rate. So you can understood now the fact which I have told you in the first slide. Okay, fine. Next, all forms of Arrhenius equation. So right now we have read about this. We have after solving of Van 't Hoff equation, we have came to this, right? This form of Arrhenius equation. Now, if we take ln, the ln form will be this one. Ln k equal to ln a minus a by RT. Fine. Now, if we convert ln to log, log k equal to log a minus ea by 2.303 RT. How it came? How it came? So, if we convert ln to log, it will be 2.303 ln k. Simple. It will be also 2.303. Sorry, not ln, log k. It will be also 2.303 log a minus, here no log is there, e by RT. Fine. So now if we divide the 2.303 for each part, with each part, then we will come to the third equation. Okay, simple. You don't have to remember this. If we remember this one only, by simple mathematical transformation, you can go to this ways. Now, if at temperature T1, rate constant is K1, it will be K1 A e to the power minus A by RT1, because it is for one reaction. Reaction is constant. Let's say A to B reaction is happening at temperature T1, rate constant is K1. At temperature T2, rate constant is K2. That time K2 will be A e to the power minus A by RT. So as the reaction is the same for both, for this reason A is also, the activation energy is same and A is also same here. Fine. Now what can we write? If we take the ratio K2 by K1 will be this. Now if we take log, so E will be gone now, and okay, for simplification I am writing here. let's say K2 by K1 will be now equal to e to the power minus EA by RT2 plus it will go to upside then plus EA by RT1. Fine, will be minus EA by R, we can take common, 1 by minus is there na, so 1 by T2 minus 1 by T1. Now if we take log both sides, then we will go to this equation. Fine, this is an important equation, please look into this. So from here also you can solve this till this equation, but it will take time when the questions is given like this way, that for a reaction at T1 temperature, or let's say 25 degrees Celsius temperature, rate constant is this, and at 30 degrees Celsius rate constant is this, and what is the accretion energy. Okay, this kind of questions can be there, so if you remember this, that will be helpful. So this is also important, and if we take the log, this will be just 0.303 will be here divided. Fine. So you have to remember these two. Here this one and here this one. And rest you can convert it. Fine. Now graphical representation of Arrhenius equation. For this, let's say, from where we are coming to this? Obviously, we have read about this, right? Right now, E by RT, right? If we take ln both sides, it will be like this. Now, ln k versus 1 by t. Ln k, this is y. So, and this is the x. So, we can write ln k equal to minus E by r into 1 by t plus ln. It will be like y equal to mx plus c, because this is x and this is y. Okay, and this will be now m or slope, and this will be what? Intercept, right? So it has negative slope. So graph will look like this, where slope will be minus negative slope, minus EA by R will be the slope, and intercept will be ln. Fine. Now for this equation, let's say this Arrhenius equation, if k versus t, if we want to plot, so we know while increasing the k, if we have seen it, when temperature is increasing, k will be increased, right? So exponential increasing of k will be there when we increase the temperature. This will be the graph for this one. Fine. Now coming to the question part, most important thing. The half-life of a first order reaction varies with temperature according to what? Okay. So we have to solve this. We previously told you, I have uploaded I think 3 videos from chemical kinetics. Yes. So if you have not watched it, please watch it, and then you will understand that what is the half-life of a first order reaction. Okay, and the rate constant, everything you can understand there. Okay. So half-life of a first order reaction varies with temperature. First, what is the half-life of first order reaction? Half-life of first order reaction is ln 2 by K. It doesn't depend on the concentration of reaction molecule. This is the important thing for the half-life of first order reaction. Okay. We know that in generally T half is proportional to 1 by a to the power n minus 1. So if you put n is here order, if you put 1 here like first order reaction, a will be 0. So it doesn't depend on the concentration of reactant. Okay, you have to remember these things. Okay, so K is here at constant. Fine. Now we know Arrhenius equation, right? Okay, let's write the Arrhenius equation also. K will be A into e to the power minus A by RT. Fine. If we take ln K will be ln A minus E by RT. Fine. So if we take, because in the options if you see ln is also there in two options, so let's try this. Ln T half will be equal to ln 2 means 0.693, so ln 0.693 is there minus ln K, right? If we put the value of this constant sum and if we put the value of ln K here, it will be minus ln K, right? So it will be minus ln A and plus A by RT. Fine. So these two are constant. Let's not think about that. And ln T half is there. So what can we say about the T half and temperature? Okay. Like this we can't understood, right? So let's see when temperature increases what will happen. When temperature increases, 1 by 3 will decrease, right? And if 1 by t decreases, this whole term will decrease, right? A by RT, whole term will decrease. If this term decreases, that time ln T half will also decrease. So we were taking T half increase, T temperature is increasing order, is increasing, right? And ln T half, we found that ln T half will decrease. That means ln T half is inversely proportional to 1 by T. So this will be the correct option. A will be the correct option. So how we got it? We know T half is this. From here, we know T half is this. We took ln both sides. This is constant, and we put the value from Arrhenius equation. We put the value of ln K. Okay. So this was negative sign. It will be now positive. Fine. Will be positive. And this constant value, if we forget about, then after increasing the temperature, 1 by T will decrease. And if 1 by T is decreasing order, this is plus sign. This whole part will be will decrease. Okay. If whole part will decrease, that time ln T half will also decrease. Okay. Like this way, you can solve these kind of questions easily. Okay. Just look carefully. Now, oh, this was from, uh, I have not written it, but this is from this is a gate question. Okay. This question is from CSI and NET June 2012. For a reaction rate constant, it is a blur kind of thing. So I will write here, very blur. I'm sorry for this. 5.4 into 10 to the power 11 e to the power minus 15. Okay, now fine. So K is here given like this. What is the activation energy for the reaction? So this is how we can solve. This is a type of question where you have to compare the Arrhenius equation, this form, of this form. Okay, E by R. You have to compare 2 with 1. Okay, because e to the power terms are there and K is there, so we have to compare with this. Only for by comparison we can solve the question. See how easy this is. So they wanted to know the what is the activation energy. So what is the P exponential factor here? This one. So I am writing A here also, and also the activation energy also I will write. So A will be 5.4 into 10 to the power 11. Okay, and is this, and EA by RT. See carefully. EA by RT will be, is it minus 50 or 50? We have taken EA by RT. Here minus is there, here also minus. So EA by RT will be equal to 50, right? So EA will be 50 into R into T. And you have to remember the all R values in different units, right? So in joule, here in the answer is given as in joule. So 50 into, in joule R value is 8.314. Okay. So 8.314 into temperature is 27 degrees Celsius, but here Kelvin we have to put. So T is 27 plus 273, which means it will be 300. 300. Now what will be the unit of this? To understand the unit, you have to know all the units of all the terms. Okay. So unit of R is joule per Kelvin per mole. Okay. And T has unit of Kelvin. Fine. So EA will be this into this, right? This is constant. R into T. So when R into T is there, Kelvin will be gone because minus 1 and here is 1. So minus and 1 will be 0. So it will be joule per mole. Okay. Like this way only you can know about the unit. Okay. And see here in the question, joule per mole is only given in the joule per mole. So what will be the answer? I am now opening the calculator. Okay. 50 into 8.314 into 300. Do it yourself. These are simple things, right? So it was 2124710. So it is approximately 125000 because no other options has the nearest value to this value. Okay. So answer will be 4. Now the rate constant for the decomposition of a molecule in presence of oxygen, R. Okay. R. Why R? At 0 degree Celsius, this is the rate constant value, and at 25 degree Celsius, this is the rate constant value. Okay. Now the question says, what is the EA? Okay. How can we solve this? I previously told you now that two kind of Arrhenius equation you should remember, and one was among these two, one was this one, ln K2 by K1 equal to minus EA by R into 1 by T2 minus 1 by T1, right? If you forget about this, just see here. Ln K2 by K1 equal to minus EA by R into 1 by T2 minus 1 by T1. Fine. Here. So T2 is the final temperature or the second temperature which corresponds to K2. Okay. So ln K2 is K2 means at 25 degrees Celsius. So this will be the K2. 64 into to the power minus. You can change the K2, you can write K2 as this also, but that time you have to put the T2 0 degrees Celsius. Okay. The corresponding temperature value you should put here. So I am taking K2 as this, then K1 will be this one, first one, fine, and minus EA by R, let's say I am putting like that. 1 by T2 will be 25 degrees Celsius, means 25 plus 273 because it is in Kelvin. Okay, 298 Kelvin. So it will be 298 Kelvin minus 1 by 0 degrees Celsius, T1, 0 degrees Celsius, 273. Fine. So if you solve this one, you will get, so R is given, so in Joule only we have to solve this. So you can do it, right? Okay, I'm just solving a little bit. You can solve it, it is very easy. Just putting value in the calculator. Okay, in gate question is this, huh? So you get the calculator here. Sorry, 2.64 divided by 0.237. So it will be ln 11.14 will be equal to minus EA by 8.314, and here it will be 298 into 273, and here 273 minus 290. Fine. So this will be ln 11. Okay. ln 11.14. It will be 2.41. So do it yourself. You have the calculator and everything you have. Don't wait for my answer. Okay. Solve it first. A by 8.314 into, this will be 298 into 273 into here 25. Fine. So these you now solve it. A will be, it will be approximately joule per mole. Okay, and you, if you want to be the answer in kilojoule per mole, then 65 will be there, right? 65 kilojoule per mole. Okay, solve it in your copy. Now next, pause the video, solve the previous question first, then come to this. Okay, so this is also a different type of question. So I have incorporated various kind of questions which are actually asked in the exam. Okay, so here you see the difference is, the first order gaseous reaction is 25% complete in 30 minutes. Okay, this is first order equation question you are thinking, but here is a twist. It is at this temperature in 10 minutes. Okay, so it is taking 30 minutes time at this temperature, and in 10 minutes time this temperature, because temperature has an effect on reaction rate. So that's why this is the change. So the activation energy of the reaction is close to. Okay, so now see, They want the answer to be in kilocalorie. That's why you have to put the R value in calorie, right? So these things actually you have to watch fast. Then you go and solve, right? Because you have solved the everything, you got the answer and it is in joule. Then this is wrong. You have to again put the value of R and calculate in calorie. So that you should remember. So first order reaction is 25% complete. So in first order reaction, the integrated rate law is ln A by A minus X equal to K into T. K is the rate constant, T is time, A is the initial concentration, X is the concentration of product in at T time, or A minus X is the concentration of reactant at T time. Fine. 25% complete means X will be 25 by 100, which will be 4. A by 4 it will be. Here is A by 4. Okay. This much reaction actually happened. So if we put the value, it will be ln A by A minus A by 4 will be K into, okay. So first it was 30 minutes. Okay, 30. Fine. This K1, let's say. Okay. So now for, because it is at T, temperature equal to 227 degrees Celsius, not Kelvin. Please see the units carefully. This is not Kelvin. Temperature is in degrees Celsius. So again, 25% happened. The reaction is right. So it will be equal to K2 into, because temperature has changed now at 237 degrees Celsius. Okay, so this will be K2 now. It will be changed, and time is 10 minutes now. Fine. These two equations we get. So here in the left hand side, these two are same. So if we divide it, we will get, because if this is 1 and this is 2, if we divide 2, 1, we will get, so 1, left hand side will be 1, right? And K2 into 10 by K1 into 30. So here the relation we get will be K2 will be equal to 3 K1. Fine. This we get, or K2 by K1 will be 3. Fine. So remove everything from here because there is another step. This is easy question, but it will take some time. Okay. So you have to have some time in your hand when you solve the question in exam hall. Okay. Now we know K2 by K1 equal to 3. So here we know this part. Fine. Now we know ln K2 by K1 is equal to minus EA by R 1 by T2 minus 1 by T2. This we know. And here T2 will be 237 plus 273 equal to 5 and 10 Kelvin. And T1 will be here 227 plus 273, which means it will be 500. Yes. will be 500K. Fine. So now if we put the value, we know ln K2 by K1 will be 3. ln 3 will be there, equal to minus EA by R into 1 by T2 minus by, okay. This you have to solve. So you know everything here. R will be 2. It is given also. So please put the value, and if we which value you get, it will be in calorie per mole. So you have to divide that value. Let's say x. So you have to divide that value x by 1000. Then it will be in kilocalorie per mole. Okay. So you solve it. Now coming to the next question. So it is also from GATE. Okay. So the specific rate constant of, it is also a little bit blur. I'm sorry for this. The specific rate constant of decomposition of a compound is represented by. Okay, I'm writing here. If you cannot see here, ln K is 5 minus 12,000 by T. Fine. 12,000 by T. The activation energy of decomposition for this compound at 300K. So T is given 300K and activation energy is they are asked. Okay. In kilocalorie or calorie, both are given. Okay. So in calorie, let's say calorie. Fine. So this is actually given. So we have to compare it with Arrhenius equation to get the EA value. So we know ln K equal to ln A minus EA by RT. We know this. If we compare this one with 2, what you will get? What you will get? You will get ln A will be equal to 5 and 12,000 by T will be equal to EA by RT. So T will be cancelled out. So see here T value is given, but T is here of no use. Okay. Now EA will be 12,000 into R. R here we should use the calorie value, which is almost 2 calorie per mole per Kelvin. Sorry, K inverse Kelvin. So it will be 2, right? It will be 24 calorie per mole. So in the options, if you see 24,000 is not here. Okay. So we have to convert it kilocalorie. So we have to divide it with 1000 and we get kcal per mole. 24 kcal per mole. Okay. This will be that. Now these are come in CSIR net June 2015. So temperature dependence of the reaction is given by this. Okay. K is equal to A T square exponential minus E0 by RT. This is given. So what will be the representation of activation energy? E0 is not here activation energy. It is an energy term. Okay. See, if you are thinking that it is Arrhenius equation only, K is there and e to the power E term is there, but it is not, because Arrhenius equation is K A e to the power minus E by R, right? So we have to convert somehow the equation to any of the form of Arrhenius equation so that we can compare it with that form and we can get the value of or representation of activation. Fine. Let's first take ln K. Will be ln A plus 2 ln T, because it will be ln A plus ln T square, and for that term ln x square term 2 will be here in front of the ln, right? 2 will be here. So that actually I have written, and here E term will be gone. It will be E0 by R. Fine. Now we know that one representation is there, ln K ln A minus E by R. This is there in Arrhenius equation. But here one T term present. T. So we can't compare this one with this one. So we could not compare with this one, and now we cannot compare with this one also. So now what is left now? What we can do here? Let's see now if we take the d ln K by d. Okay. So one another form is only left here, d ln K by dt. Okay. So if we take it is constant, it will be 0. Fine. Here 2 will be there and it will be 1 by t. Right? And it will be E0 by R, and the uh, derivation of 1 by t will be 1 by t square. Yes, it will be minus 1 by t square, so minus minus here it will be plus. What is there now? 2 by t plus E0 by RT square. But we can't compare now also, because in that form of Arrhenius equation, there is dln K by dt equal to A by RT square. That is there only, right? If you have forgotten about it, I will show you again after solving of this. Okay. So now if we can, so we have to convert it somehow to this form. So RT square should be common. Okay. If we take RT square, 1 by RT square as common, then the left part will be EA, because only these two terms are there. So now we are taking 1 by RT square as common. Just take common and see what is left now. So if we take RT square as common, the RT square will be multiplied in the upper portion. Okay. So it will be 2RT, 1T will be cut out from here, and plus E0. Okay. So now this is d ln K by dt equal to. So now if we compare this one with these two, what we can get? Just remove these things. It's very important derivation. Okay. And see, it has it is a question of PYQ only. I'm taking only the PYQ question also, so that you have the idea about the all kind of questions. So it is a very different kind of question. So let's see now the uh, the the derivative form we got is 1 by RT square into 2RT plus E0, and we know these things from where? From Van Hoff equation. If you forget about this, let's see this. Here this one we got now, d ln K by dt equal to A by RT square, right? So I was talking about that equation only here. Okay. So if you now compare 1 with 2, what we got? So RT is 1 by RT square, 1 by RT square is there, only EA is left, and left hand side is also same. So EA will be now this one, 2RT plus. Is it in options? Yes. So C will be the correct answer. You understood this? This is given, so you have to somehow relate it with Arrhenius equation, but it is not here. T term is there, so just forget about everything. Just take the ln. Okay. When we took the ln also, there was some term. We can't compare it with this. There was some term, T term, temperature term was also there. So now one thing is left only. If we take dln k by dt, so we took that and we have taken this as common, and now 1 by rt square as common. Now we got this one left. Okay, so we can put a like this. So a will be e0 plus 2r. Fine. Now, one simple thing I want to show you, because from here also questions are asked, overall EA and free exponential factor. So, in which cases we need this overall EA or overall free exponential factor? Let's just see this kind of complex reactions are going on, various steps are there, and for A to P reactions actually, the 1, 2, 3, 4, 5, 5 steps are there, and associated rate constant values are these. Okay, and it is saying that in the question it is given that rate is depending on k1 into k2 by this. So rate depends on this equation. It follows this equation. So what will be the overall EA expression and overall exponential, P exponential factor? So if you see that rate is proportional to this, means K average or overall rate constant, this one will be equal to K1, K5, K2, K3 and K4. Okay, this is experimentally they got. Okay, now what we can do? We can put the values of Arrhenius from the of the rate constant from Arrhenius equation. Will be A average e to the power minus E A average, let's say RT, equal to, here if we put, it will be very big value. This is just for, I want you to understand this, that's why I am putting all the values. E5 by RT, here it will be A2 into e to the power minus E2 by RT, and again A3 e to the power minus E3 by RT into A4 e to the power minus E4 by RT. Okay, now if we solve this and take the A1 like this way, okay, it was not like that. Okay, let's say this was like 1 by 3 to the power 1 by 3 is there. Okay, so this whole term is now 1 by 3. Here is also 1 by 3 is there, right? So if we take here A1 into A5 into by A2 into A3 into A4 to the power 1 by 3. Okay, we took this, and other e to the power terms are only left here. So let's simplify that. Simplifies 1 by RT I have taken common and minus also. So E1 was there. Okay. Okay. First let's write that only E1. Here also minus sign was there, so it will be plus E5. Here minus sign is there, but it is below, na. So if you go to upside, this e to the power term, e to the power minus e2 will be positive. It will be plus e2 by RT. So then again minus I have taken common, so it will be e2. Just simple mathematics. E3 like the same way, it will be also e4. Fine. And what we can do about 1 by 3? It will be just multiplied there, right? Here it will be power, and here it is already e to the power, so it will be just multiplied here. Fine. Now if we compare this, like it is A average and e to the power minus E average by RT. What will it be? If we compare this, A average will be this one, this whole, and E average will be, let's say here only minus 1 by RT is present. Let's forget about now the minus 1 by RT. So 1 by 3 and this whole term will be the E average. Simple. So E average will be this one, 1 by 3 is here multiplied, and E1 plus E5 minus E2 like this. Okay, which we solve, and A average will be this one. It is actually to the power 1 by 3. Fine. So this is fine, but for question solving in the exam hall, it will be very difficult because various terms are there. If you forget about one or if you make any mistake about plus and minus, then the terms are will be different. Okay. So for that, I will I will simply say you the a trick. I will tell you about a trick. So let's forget about everything here. So in the exam hall, if you know this trick, it will be helpful for question solving. Okay. So if any kind of this is given or rate constant is depending on K1, K2 by K3 to the power 1 by 5, this kind of terms are given and you are asked that what will be the E average value of this reaction. Okay. Simply, you should not write the everything like the from the Arrhenius equation, put the every value and then solve. No, you just write E average will be the here K1 is there, so it will be E1. K2 is here multiplied, it will be K2, E2. K5 is here divided, then minus E3. Okay, and whole to the power 1 by 5 is there. What should we do? 1 by 5. No other like coefficients and nothing will affect here. Only you see the how the K1, K2, K3, etc. terms are actually related. Is it multiplied or divided? With that only, if it is multiplied, you take plus. If it is divided, you take minus. And if any other power is given for the whole value, that will be only multiplied. Fine. Then if you just apply this trick to this, you can see it's that what is given here. K is K1, K5, K2, K3, K4. Okay, to the power 1 by 3. So now 1 by 3 will be multiplied and E1 plus E5 minus E2 minus E3 and minus E4. See, same value actually we got. We have to just see that what is the power here. Nothing. If every coefficient is also there, it will not affect in the activation energy. Okay. Only the K1, K2, K3, etc. are in what relation. It is if it is multiplied, it will be the energy will be in plus sign. If it is divided, then energy term will be in minus sign. And if it has any power, it will be come like a multiplication. Fine. And overall AV will be just the A1, A2 like that only. This one. Like that only the A average will be the like the rate constant. Okay. The uh, same form will be there for A average. Okay. Let's take a question. CSINA June 2012 question this is. So here rate is given like if you see here it is rate follows the this order. So K is here K2, K1, wrong it is given right. 1 will be K2. Okay. Let's see what will happen. We will match with these answers. Okay. So now we know that E will be, E average will be, here it is written like EA for 2, EA for 1. Okay, right like that. So K2 is multiplied. So EA for 2 will be there. Plus K1 is also multiplied if you see. If it is K1, I don't know it is K1 or K2. Okay, just see. Forget about this. Let's just think that it is K1 and below this is K2. Okay, so it is to the power. It will be now multiplied. Fine. Just so it is EA2 and plus it is to the power form, power is there, so it will be multiplied, and let's say it is K1, so EA1 and minus 2 will be not considered here because this coefficient has no value here. Okay, so just forget about that, and EA2 will be there. Okay, just that. Okay, let's see if any option has this. Actually, it is wrong. A4. What is 4? T should be there, na? It is wrong. Here 2, K2 is given. Here K1. It should be K3. These or these should be K3. And in the answer, it is given 4. Okay. So it is a wrong question. So I'm sorry, I should check this. In every option, see, EA2 is there. Okay. And half will be multiplied between the other terms. With the other terms. Okay. So here is only 1/2 is there. It will be wrong. Here 2 is there. 2 will be obviously not here because it is only coefficient. Here half is there, here half is there, and here if half is there, here half is there. So answer should be between C and D. Okay, fine. Now, one plus sign, one minus sign, and one minus, one plus. So if let's say this is K1, what is given, and it is K4, then half into EA1 like this, and minus half into EA4 or 3, let's say. So C will be the option. The question is not correct, fine, but we can solve it to the by cancelling out the other options. Okay, so C will be the correct option. So you understood, like, if right, if let's say I am giving one question, so let's say K1, K2, and by K3, okay, and K4, K5 to the power 1/5. This is the equation for K. This one. Okay. So what will be the E average for this? Just we will see the K values and we will put the E values for that corresponding K. Okay. So E1 plus, because multiplication is there, E2, so it is divided, minus E3, fine, minus E3, and for these two actually 1/5 is multiplied. So we will write plus 1/5 into y plus, because K4 is multiplied with this. Okay. So E4 minus, because it is divided, E5. Fine. For this kind of equation, it will be the E average. Fine. If here 2 is given or here 4 is given, nothing will be there in for that coefficient, nothing term will be there for E average. Fine. Only which are the power in the power that will be multiplied, and the rest things, if it is multiplied, it will be the plus sign will be there, and if the term is divided, that the corresponding energy has the minus sign. Fine. I hope you understood these topics in a clear way. I have taught you, or I have shown to you all kind of questions which are actually coming in the CSI and NET and GATE. Okay. Some tricky problems are there, but if you know, if you understand the theory and the equation properly, you can solve it. Okay, so hope you understand and enjoyed this session, and thank you so much for your patience. See you in the next video. Okay.